power series, and it makes your life so much easier. So remember, if it's geometric, what does it converge to? A over 1 minus r. So if you have a function set up a over 1 minus r, a over 1 minus r, then you can go straight into the series for your a and your r. So in this case, I would put my a is going to be 1, my r is going to be x, and there's your power series. Instead of taking all of those derivatives and then getting it to the pattern, kind of like over there on the board, right? And then writing the series from the pattern, boom, you're done. I told you would love notes today, right? Okay. And where are you centered? 0. You're centered at 0 in this case. All right? What would be your interval of convergence? What do you know for geometric? The absolute value of r has to be what? Less than 1. So that would be what? Do you have to check endpoints? No! You don't have to check endpoints because it's geometric! Yay! Alright. All done. Life is easy. We love geometric. Okay? So, we do not have to check endpoints for a geometric power series because the endpoints diverge. Why do you have to check for ratio and root? Because the endpoints would be what? Inconclusive. So you'd have to go and check those individually.
So that's R when
So it diverges, it's included. Okay? So I don't have to check the endpoints. Alright, so I'm going to show you this, and then if you want to write it down in a second, bless you. But now let's say that I wanted to take this power series that we just had and now center it around -1 instead of 0. So what I'm going to do is I'm going to take x minus a -1, right? But minus a -1 would be a plus 1. So now I've got that centered at -1. Well, I can't just throw something in without, like, keeping it mathematically sound. So that's actually a -1 that we just put in. So to balance it, I'm going to add 1. So then I can do 1 plus 1, which would be 2. But I need a over 1 minus r here. So what do I have to go through and do? Divide everything by 2. And now I've got my a over 1 minus my r. Okay, see if you can write that in your notes, trying to look up minimally. And then we'll talk about the rest here in a second. So you can get it to that to adapt. So after I've got it here, now I can go ahead and write my power series by putting in my a and my r. So if I have that, we can find the interval of convergence. So I know my r, absolute value, has to be less than what? Well, I can pull out the absolute value of 2, right? That's just 2. Multiply it over. So I have this guy. Where am I centered? Centered at -1. What's your radius of convergence? 2. So now let's go find our interval of convergence. So when I'm centered here at -1, I'm going to go out 2, right? So what's that interval of convergence going to be? Well, we could do some math, or we could visualize it. So I could drop my absolute values and get the, split it up. So that would be what? 1 and -3. Does that make sense? Going out 2. Do you have to check endpoints? No, you don't, because it's geometric. Okay. Now, what if I asked you to find the first 3 non-zero terms, or find the third degree Taylor polynomial here? Would that be pretty easy to do? Let's nod our head. Yeah. Sure. What did you say, Mr. Alright, so if we do that, let's put in a 0. What do I get out? 1/2. There's your first term. Let's put in a 1. What do I get out? There's your next term. Let's put in a 2. What do I get out? X plus 1 squared over 8. So there's your third degree Taylor polynomial. Or second, sorry. That's your second. So you can do it one more time if you want to get to the third. I just kind of ran out of it. Sorry. But you get the gist. So instead of taking this original, doing all the derivatives, plugging in -1, writing out the whole pattern part, and then simplifying, you could do this. Yes. Whatever you want. If it's set up in A over 1 minus R, go for it. Make your life easier. Okay? Okay. So let's look at this next one. Let's do one more together. What? Oh, no. This actually occurs a lot. Yeah. Okay, so let's first center it at -2. If it said centered at 0, we're done. But this one's it's centered at -2. So I have 5 minus x plus 2, but I actually put in a -2, so I need to add 2. Now you're so quiet over there today. Isn't it crazy how, like, breaks make you even more tired? Get you off your schedule. Alright. So that would be, oh sorry, what's that start key? I'm not gonna lie, I was really hoping we wouldn't have school today. I just wanted one more. I know, isn't that horrible? I'm sorry, we should not do that. Just one more. Alright, so we got this center. Who do I want to pick on? Kim, what do I need to do now? Why? Right, because you need a 1 there. So let's divide everything through by 7. Now write your series, Kim. This one's all you. I'm going to keep picking on you. Okay. So tell me what to write, Kim only. Start where? Good. I don't know why I'm but I better go. Yeah, so. Alright. What's your interval of convergence, Kim? You're centered where? And your radius of convergence is? Radius of convergence is 7. So now let's continue. What's my interval of convergence? Okay. And do you have to check endpoints? No? Why? Geometric. And if I asked you to find the second degree Taylor polynomial, could you do that? What would you plug in? Give me your first 3 terms here. Uh-huh. Plus or minus? Let's do one more. Give me a 7 cubed. 343. You could have just wrote 7 cubed. So what would that be up here? Alright. Alright? You guys try this next one. Now, if you want to do it out the long way, feel free. You can take some derivatives. Let me see the pattern.
Alright, don't do.
You can pick, it's up to you. You could use the ratio test. I wouldn't advise it. You're not?
Yeah.
Is plus the same as minus and negative? so this is what you should get. You know, if you need help with this. So that would be your power series. How do you not get that? And then your interval of convergence. Is this. Make sure you can get that. If you need help, let me know. Stop. Stop. Did you make an igloo for real? Did you take a picture of it?
Yeah.
I want to see it after that.
I can almost see it.
myself. I went down like 3
It's not actually igloo. It's because I didn't actually make it because like
Alright. Anybody one more time? Everybody got this. Anybody want to slap Matt on the head right now? Stop! Okay.
Whoa, what's that?
So, A doesn't have to be a number. Dot urgency. A does not have to be a number. You did? Oh, good. So, what would this power series be? Uh-huh. Uh-huh. Okay. Sure. No. No. So what would it be if you wanted one X? Yeah. 3n plus 2, that kind of looks weird. Yes. There's your power series. Done. I don't care if you leave it like this or like this. Doesn't bother me either way. Alright? Just make sure that it was a multiple choice. You don't choose this one.
Yeah.
Okay, sorry, that was me. Alright, so now find your interval of convergence. So that's what he had said. Yeah. Interval of convergence. So it's no longer going to just follow the whole like drop and split rule. You're going to just have to think logically. So here your R has to be less than 1, right? So logically, what is X going to have to be between? Yeah, -1 and 1. Yeah, but it's a little different. Like, especially when you get to like square roots, then you're gonna have like imaginaries and. Okay.
Gotcha.
Okay. Do you have to check in points? No. Write your first 3 terms.
So why are we writing all the 3 terms?
Just because.
Just for fun.
Well, it's something that you could be asked to do. You may be asked to write the power series. You may be asked to find the interval of convergence. You may be asked to find the 3rd degree Taylor polynomial. Okay? So that's actually fine. Let's write this out. If they asked you in a question, if I asked you on a test from here to write the 3rd degree Taylor polynomial, centered at 0. All you need is like 30 seconds, not even. Plug in 0. Plug in 0. What do you get out? X squared. Well, I guess I really don't want the third degree. We'll just say the first 3 non-zero terms. How about that? Okay? Let's do the first 3 non-zero terms. Alright, what's your next one? X to the 5th. What's the next one? X to the 8th. There's your first 3 non-zero terms. Done. Nat, do you understand how we do it that fast? Alright. Okay, do the next one. Yes. Evan, what's wrong with this one? Okay. It's not 1 minus something, so what do we have to do? Hun, how did you do that?
I rearranged it.
Perfect. That's exactly what I did. So now what's your A, McKay?
I got A over X. Because, like, I divided by X.
Okay. That's harder. Because now, like, you're dealing with something different. I don't know how to explain it very well. So, I know. So she said if I divided through by x squared everywhere, right? It would look like that. Okay, so let's continue. Let's see what happens if I write those two summations. Alright? What would this one be? Negative x, right? And then, oh yeah, n equals 0, thank you, to infinity. X squared to the n, and let's write out the first few terms. You're adding 2, right? Alright, so let's look if I did this one. See how that's completely different?
Why is that though?
I don't know how to explain it yet. Can I get back to you on this? I think of a better way to explain it for you, okay? We actually had one like this on that intro worksheet that I gave you. Do you remember the intro worksheet to this chapter? I know that was like 2 weeks ago now. But it was set up very, very similar, like this. So let me try to formulate a really good response for you. But this is the wrong way. This is the way you'd want to do it.
What is it? Give you a wrong answer.
Yes. Okay. And I gotta remember it's in the centering and things that's going on here. Okay. Okay. And I'll try to think of a better way to explain it for you. Sorry.
So,
All right.
what happens to the because both examples, like both the answers will not be
They won't. They won't. Okay. So here, these are just some operations with power series. If you have f of x and g of x, now if you're going to go put in kx into the power series, make sure it's kind of like saying kx to the n when you put it in, and then you can distribute the n's. Okay? to both of those. Is that alright? Okay. If I had x to the n, then I would multiply when I put it in, x to the n. And if they both have x to the n and x to the m, you could actually kind of factor it out and just put the a sub n plus or minus the b sub n part. So this is kind of common sense things, but just to make sure you've at least seen the rules. Alright, so last one we're going to do. Oh man, this is geometric. Arctan x. Huh? It is something you're supposed to memorize, yes. Okay, if you got it memorized, sweet, you don't have to do any of the work. So let me show you where this comes from. Now, we're like, it's not geometric, so I'm going to have to do out my derivatives, write my whole polynomial stuff, until I see a pattern, then I can write the series. Right? Are you sure? That's all I know how to do right now. I don't. So I'm gonna go ahead and give my first derivative. What's the derivative of arctan? All right. Oh, hold on though. This is geometric. I can write a series for this one. All right. So let's see. That's the same as 1 over 1 minus negative x squared, right? Oh my gosh. All right. And this would be the summation from 0 to infinity of 1 times to the n. But that's for g prime. I don't want g prime, I want g. Well, last time we saw each other, we know that we could do what with series? We can integrate them. So I could integrate the series to get back to g. So before I do that, though, I would want to rewrite this so that I have my a sub n pulled out from my the rest of it, like the x. Okay? So I'll have a negative 1 to the n times x to the 2n. So I would want to rewrite that so that I can integrate it. So now g of x is going to equal, do I have to jump forward or backwards when I integrate? No. The only time I jump forward is when I see the derivative. Bless you, Q. You're welcome. Alright. So coefficients go along for the ride. Woo! This would be x to the 2n plus 1. Do I do the plus 1 in parentheses? No. The only time you're going to use those parentheses is if you were like changing from a 1 to a 0. But we're not doing that. We're just doing plain old power rule here for an antiderivative. Divided by 2n plus 1. There you go. Did you have that memorized already, Evan?
No, that's it written down.
Oh, alright.
I mean, I do.
Alright. So that's where it came from. You could continue to take the derivatives and then plug in 0 and then write this out. Yes. And I forgot to show you guys We didn't do it last time. I don't know why we didn't do that slide last time. So you have to see the joke from last time because it's pretty funny, especially if you're in math club. Okay, now this, I'll go ahead and stop the recording. But, oh well.
Harlem Shake.